Okay, so we want to multiply both sides of this equation by 16. That's supposed to clear the denominator, and that's something universal that we've been talking about ever since almost the first day of class. So we want to make sure we understand how to do this. It's a very important operation. You're going to have to do it in your class. Okay, so we take this and we distribute, and we get 16x squared plus 16x squared over 16 minus 16 times 30x over 16. And I don't want to multiply the 16 by the 30, because this 16 divided by this 16 just gives us 1. We don't want to disguise that fact. We're going to see how this works out, because again, cancellation is a big problem. We're not going to use it. You have to understand fractions well enough to understand that 16x squared over 16 is the same as 16 over 16 times x squared over 1. Because if I multiply the numerators, what do I get? I get 16x squared. If I multiply the denominators, 16 times 1 is 16. So this is identical to this. But 16 over 16 is just equal to 1. So we're just going to end up with an x squared there. We don't want to shortcut that, because I'm pretty sure if you start shortcutting, errors are going to crop in. Of course, this is something you kind of got to get used to doing, because you've just been taught to cross lines through things that look the same without really being required to understand why the rules work. I don't think it's a good idea to teach it that way. No offense to your teachers. It's what the curriculum does. But I think it's a bad idea, so I don't do it. Okay, now I'm not going to go through the gory detail. I went through the gory detail previously with a different set of fractions. But 16 over 16 is 1. X squared over 1 is x squared. And you have 1 times x squared, which is just x squared. So that's why this thing becomes x squared. Similarly, this becomes minus 30x, because that 16 over 16 is just a 1. Then another thing people do, they cross it out and think it disappears. No, it's 1. And then when you multiply whatever you got here by 1, well, you just get whatever you got here. And this is 30x over 1, and of course dividing by 1 just gives you a 30x. And it's a negative, of course. And this is plus 225 equals 0. So now we've got 17x squared minus 30x plus 225 equals 0. Now let's remind ourselves of where we are.
Quadratic formula.
We got this mess, right? We're trying to find the zeros, which is why we wanted to put this mess into this equation. Well, we wanted to put this equation, which is what we have here, set this equal to 0. We see we need some simplification. We have an x squared and an x squared over 16. We could have multiplied the x squared by 16 over 16. We get 16x squared over 16, and then added these fractions. But I prefer to emphasize, in this case, just from what I've been seeing, that we multiply both sides by 16, because that's the common denominator. Then we run through the algebra and we do it carefully, so we do it accurately. And we get this equation. I could say zeros are absolute, just say zeros are, because zeros are just numbers. Negative 17 plus or minus the square root of 17 squared minus 4 times 17 times 225 less 11. That isn't too bad to multiply. This 4 times 225 is 900, and you do 9 times 17. But we're not even going to mess with that. And this is over 2a, which is 2 times 17. And you know what I just did? And I've done this before. Writing this down, not looking carefully at what I'm looking at. I was totally wrong, but we can plug it into the quadratic formula and you can verify. But b is negative 30, not 17. I didn't catch my error until I started dividing by the 2a. We get negative of negative 30 plus or minus the square root of negative 30 squared minus 4 times 17 times 225. All that divided by 2 times 17. Well, this is kind of unfortunate because we don't get any zeros. Although that's not a problem, we can still solve the problem of what the minimum is. Okay? If you evaluate this, you can see pretty immediately, 30 squared is 900. 4 times 225 is 900. And you got 17 times that you're subtracting from 900. So you're going to get like negative 16 times 900. Okay? Which is like 14,400, I think. Okay? So it's a big negative number. You're not going to get zeros. What does that mean? That means your parabola is above the x-axis or all the way below it. It doesn't go through the x-axis. Your vertex is at x equals negative b over 2a. This, which equals negative of negative 30 over 2 times 17. Which is 30 over 34 or 15 over 17. The y-coordinate of the vertex you obtain by plugging this into this expression. Well, And I just, okay, that would give you the minimum of this thing, okay? Just carelessly wrote that down. It's the minimum of the x squared plus y squared. Original function, because this isn't the function we're trying to minimize. We got this by solving this equation here. This is our x squared plus y squared function. Now, the vertex of this function is going to be the same as the vertex of this function. We have the same zeros, the same vertex and everything. But we don't plug this into the rearranged equation. We plug this into the original equation. Okay, well, that's a big exercise in algebra. The main thing that we've done is we started with this thing. We wanted to find the minimum of x squared plus y squared. We solved this equation for x, or sorry, for y, and we got this, which we then plugged in for y in this expression, which gave us this, and this simplifies to this. So this is the expression x squared plus y squared in terms of x. It's quadratic. To find the minimum, we want to find the vertex. And this, of course, goes back to everything we said here. This is basically what you need to understand about quadratic functions. And if you understand most of the bits and pieces of this, that's okay. It's better if you understand it completely, because then you'll be much better when you hit it in your pre-calculus. Okay? Have you hit it in pre-calculus yet?
It doesn't start till October 20th.
Okay.